Hi learners! In today's video, you will learn how a geometric figure is translated in the coordinate plane. You will also learn how to write the coordinate notation to describe the translation rule that maps the preimage to the image. With the translation rule and the preimage, you will be able to identify points that are on the image. Once points are identified, graphing and drawing of the image when needed will be easy for you. Finally, we will analyze and answer sample problems to let you experience how these are done so that you will be able to successfully solve geometry problems similar to this in the future. If your lesson is on translation, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. Let us recall what a translation is. A translation is a slide or a push done to an object or a geometric figure. In translation, the preimage and the image are congruent. That is, the corresponding angles and corresponding sides are preserved after the translation. Here, we say that the preimage triangle NFH is congruent to triangle N prime, F prime, H prime, the image. Learners, you have to remember that orientation is also the same before and after a translation. What is changed is the location of the image. Let us have quadrilateral NFDC on the coordinate plane. Quadrilateral NFDC is transformed to form quadrilateral N prime, F prime, D prime, C prime as shown here. Can you tell what type of transformation mapped quadrilateral NFDC to quadrilateral N prime, F prime, D prime, C prime? Right, translation. What is in the illustration that tells you that translation took place here? You are correct. The orientation of the preimage and the image are the same. What else? You're again correct. Quadrilateral NFDC is pushed to the right and then pushed down, producing quadrilateral N prime, F prime, D prime, C prime. Look at the image, learners. What can you say about the size and the shape of the image? You're right. The size and the shape of the image is the same as the size and the shape of the preimage. But how will you verify this? Like the size. The sizes can be compared by determining the lengths of the corresponding sides. You can do this by counting the grids covered by the sides. We will start with side FD, then side F prime, D prime. Let's go. Counting on FD, we have 1, 2. On F prime, D prime, we have 1, 2. These corresponding sides have the same length. Okay, let us check side DC and side D prime, C prime. On DC, we count 1, 2, 3, 4. Then on D prime, C prime, we have 1, 2, 3, 4. These corresponding sides have the same length as well. Let us check side NC and side N prime, C prime. On NC, we count 1, 2, 3, 4. And on N prime, C prime, we count 1, 2, 3, 4. These corresponding sides have the same length as well. It therefore follows that side NF and side N prime F prime have the same lengths. From here, we see that the corresponding sides have the same lengths. If we put one figure on top of the other, one will exactly fit onto the other. In such case, we say that the corresponding angles are also congruent. You have to remember this, learners. After a translation, the corresponding sides and the corresponding angles of the preimage and the image are congruent. The previous statement strongly suggests that if two figures are congruent, there must be a rigid transformation that took one figure onto the other, right? Here, that rigid transformation is translation. Before we go further, let us first consider these important concepts which we will use in writing the translation rule. On a coordinate plane, a slide or push to the right or left is along the x-axis, also called the horizontal push. A push to the right means adding number of units to the x-coordinate. A push to the left means subtracting number of units from the x-coordinate. On the other hand, an up or down push is along the y-axis, also called a vertical push. A push going up means adding number of units to the y-coordinates. A downward push means subtracting number of units from the y-coordinate. A summary table is shown here. The table shows the type of push or slide done on the preimage and how it is reflected on the coordinate notation to describe the translation rule that maps the preimage to the image. The coordinate notation to describe the translation rule that maps the preimage to the image has this form. Here, the coordinates of a point on the preimage, xy, is mapped to produce the coordinates of a point on the image, x plus minus a, y plus minus b, where a is the horizontal push or slide with positive when the push is to the right and negative when the push is to the left. B is the vertical push or slide with positive when the push is up and negative when the push is down. We will use the example that we have started here and come up with the translation rule that mapped quadrilateral NFDC, the preimage, to quadrilateral N prime, F prime, D prime, C prime, the image. Let us look at this illustration again and trace what motions took place. We will focus on a pair of corresponding vertices, points F and F prime. Our aim here is to obtain the values of A, the push along the x-axis in terms of the number of units, and B, the push along the y-axis in terms of the number of units, so that we can plug those into our coordinate notation that will define our translation rule. Let's go. Okay? F is pushed 5 units to the right, which means adding 5 to x. And 6 units down, which means subtracting 6 from y. Now, our coordinate notation is complete. This notation describes the translation rule that mapped point F to point F prime. What does this mean? It means that any point or every point on the preimage will be mapped following the translation rule to produce the image. Let us find the coordinate of F prime, the image, by using the rule. Then later, we will verify if this rule is correct by getting the coordinate of F prime from the graph. Let us do it. We start by getting the coordinate of F from the graph. From point F, move down to the x-axis to get the x-coordinate. It is -4. From point F again, move towards the y-axis to get the y-coordinate. It is 5. Therefore, point F has the coordinates -4, 5, where -4 is the x-coordinate and 5 is the y-coordinate. We now replace the x and y coordinates on our translation rule. Simplifying the numbers on the image side gives us, thus, F, a point on the preimage with coordinates -4, 5, is mapped to F prime, a point on the image with coordinates 1, -1. Let us find the coordinate of F prime in our graph and see if it is really 1, -1. Let's go. From point F prime, move up to the x-axis to get the x-coordinate. It is 1. From point F prime again, move towards the y-axis to get the y-coordinate. It is -1. Therefore, point F prime has the coordinates 1, -1, where 1 is the x-coordinate and -1 is the y-coordinate. The very same coordinates we got using the translation rule we obtained earlier. So, remember this, learners, if we have the preimage and the coordinate notation for the rule, the translation rule in this case, we can locate the image, and drawing the image, if no drawing is present, can easily be done. Try to determine the coordinates of D prime, C prime, and N prime by applying the translation rule. The coordinates of D, C, and N are determined for you. I am sure you will be able to do those. Anyways, we have here the coordinates of the corresponding vertices, D prime, C prime, and N prime. You can check your work with the coordinates of the vertices of the image here. Let us work on sample problem 1 to check our understanding of the concept we just learned. Here is the problem. Identify the rigid transformation, then write the coordinate notation to describe the transformation that maps the preimage to the image. A figure is given. Take note that the image has the prime notation in the illustration. We begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for here, learners? There are two things that we're looking for here. First, we have to identify the rigid transformation that took place. And second, we have to write the coordinate notation to describe the transformation that maps the preimage to the image. A figure is given here. Let us examine the figure. What is the first thing that you notice on the figure? You're right. The preimage and the image have the same orientation. What else do you notice? Correct. The preimage is pushed to the right than up. What do your noticing suggest? That since the preimage is pushed to form an image of the same orientation, the transformation that took place is translation. There you are, learners. We have just identified the rigid transformation that took place. Translation. Now we move on to determine the coordinate notation that describes the transformation that maps the preimage to the image. Since we now know that translation occurred, we use the form for the coordinate notation that maps the preimage to the image for translation, which is xy is mapped to x plus minus a, y plus minus b. Here, we simply need to determine a, the motion along the x-axis, and B, the motion along the y-axis. How do we do this? We trace and count the moves. To make the process easy, we focus on one corresponding points. Let us focus on N and N prime. Let's go. From N, we move and count the moves to the right and stop just below N prime. Here we go. 1, 2, 3, 4, 5. And since the push was to the right, we put a positive sign before 5. So A is positive 5. From where we stop, we move up and count the moves until we reach N prime. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Take note that the moves were going up, so we have to use the plus sign. So B is positive 9. There you are, learners. We have the coordinate notation to describe the transformation that maps the preimage to the image. This is our translation rule. Again, our answers are: the rigid transformation that took place is translation. Second, the coordinate notation to describe the transformation that maps the preimage to the image, which is translation, is xy is mapped to x plus 5, y plus 9. There you are, learners. That was easy, right? Let us have sample problem 2 this time. Triangle GAH, shown below, is translated 5 units to the right and 3 units down to produce triangle G prime, A prime, H prime. If the measure of angle G is 100 and the measure of angle A is 50 degrees, which statement about triangle G prime, A prime, H prime is true? A, the measure of angle G prime is 50 degrees and the measure of angle A prime is 100 degrees. B, the measure of angle G prime is 130 degrees and the measure of angle A prime is 50 degrees. C, the measure of angle G prime is 100 degrees and the measure of angle A prime is 50 degrees. D, the measure of angle G prime is 150 degrees and the measure of angle A prime is 30 degrees. We begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for here, learners? You are right. We are to determine which statement about the angle measures of the image is correct. Okay, so what are given here? That triangle GAH is translated 5 units to the right and 3 units down to produce triangle G prime, A prime, H prime. An accompanying figure of the preimage is given, and the measure of angle G is 100 and the measure of angle A is 50 degrees. Okay, let us analyze what are given here. The triangle is translated. What does it imply? Okay, it implies that the preimage and the image are congruent. What does it mean in terms of the parts of the triangle? Now, it means that the corresponding parts are congruent. Since the problem's focus is on the angles, then we say that the corresponding angles are congruent, right? In particular, it means that the measure of angle G is equal to the measure of angle G prime equals 100 degrees. In like manner, the measure of angle A equals the measure of angle A prime equals 50 degrees. There you are, learners. We can now examine the options and determine which statement is true. Let us start with option A. The measure of angle G prime is 50 and the measure of angle A prime is 100 degrees. Is this statement true about triangle G prime, A prime, H prime? No, it is not. Let us go to option B. The measure of angle G prime is 130 degrees and the measure of angle A prime is 50 degrees. Is this statement true about triangle G prime, A prime, H prime? Again, no, it is not. Let us go to option C. The measure of angle G prime equals 100 degrees and the measure of angle A prime is 50 degrees. Is this statement true about triangle G prime, A prime, H prime? Yes, this statement is true about triangle G prime, A prime, H prime. Let us go to option D. The measure of angle G prime is 150 degrees and the measure of angle A prime is 30 degrees. No, the statement is not true. So our answer here is option C. The measure of angle G prime is 100 degrees and the measure of angle A prime equals 50 degrees. There you are, learners. That was easy again. We did not even go into drawing the image. All that is needed is for us to know that in translation, corresponding parts are congruent. Let us do sample problem 3. Rectangle RJLH, shown below, is translated 7 units right and 2 units up to produce rectangle R prime, J prime, L prime, H prime. Which statement about the side lengths of rectangle R prime, J prime, L prime, H prime is true? A. The length of R prime, J prime is 3 and the length of J prime, L prime is 7. B. The length of R prime, J prime is 10 and the length of J prime, L prime is 9. C. The length of R prime, J prime is 7 and the length of J prime, L prime is 10. D. The length of R prime, J prime is 3 and the length of J prime, L prime is 9. We begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for, learners? We are to determine which statement about the side lengths of rectangle R prime, J prime, L prime, H prime is true. What are given? That rectangle RJLH is translated 7 units right and 2 units up to produce rectangle R prime, J prime, L prime, H prime. A figure is given. Now, we will take a closer look at the given information and figure out which of the information will help us find what we are looking for. It says here that rectangle RJLH is translated 7 units right and 2 units up to produce rectangle R prime, J prime, L prime, H prime. Okay, so translation took place. What does it imply? It implies that the preimage and the image are congruent. What does it mean in terms of the parts of the rectangle? The corresponding parts are congruent, right? Since the problem's focus is on the length as seen on the given options, then we will capitalize on the statements which says that the corresponding sides are congruent. This means that the corresponding side lengths have the same measure, right? Let us look at the figure so we can determine the exact length of each side of the rectangle. We do not have to draw the image here, learners. All we need to do is get the corresponding sides from the names of our rectangles by following the order on how the letters are arranged. A discussion on this is in our video on Introduction to Rigid Transformations. Watch it if you have not done so. A link is provided here. Let's go and determine the lengths of the corresponding sides. Since only side R prime, J prime and J prime L prime are in our options, then we will focus on side RJ and side JL, the corresponding sides of R prime J prime and J prime L prime respectively. Whatever the length of side RJ is the same as the length of side R prime J prime. In like manner, the length of side JL is also the length of side J prime L prime. Let us count the grid that is on side RJ to get its length. So we count 1, 2, 3. So the length of side RJ and side R prime J prime are both 3 units. We now count the grid that is on side JL. We count 1, 2, 3, 4, 5, 6, 7. So the length of side JL and side J prime L prime are both 7 units. There you are, learners. We can now determine which statement is true about the side lengths of rectangle R prime, J prime, L prime, H prime. Let us look at option A. The length of R prime, J prime is 3, and the length of J prime, L prime is 7. Is this statement about the side lengths of rectangle R prime, J prime, L prime, H prime true? Yes, it is true. Let us look at option B. The length of R prime J prime is 10, and the length of J prime L prime is 9. Is the statement about the side length of rectangle R prime J prime L prime H prime true? No, not true. Let us look at option C. The length of R prime J prime is 7, and the length of J prime L prime is 10. Is this statement about the side lengths of rectangle R prime J prime L prime H prime true? Again, no, not true. Let us look at option D. The length of R prime J prime is 3, and the length of J prime L prime is 9. Is this statement about the side lengths of rectangle R prime J prime L prime H prime true? Again, no, the statement is not true. So our answer is option A. The length of R prime J prime is 3, and the length of J prime L prime is 7. There you are, learners. That was easy. Again, it was not necessary to draw the image. All that is needed is for us to know that in translation, corresponding parts are congruent. Another way of doing this is to get the translation rule. Then apply the rule to locate corresponding vertices on the image and draw the rectangular image. From the image, determine the side lengths just like what we did earlier. Okay, let us do the last sample problem. Sample problem 4. Translate triangle AHM 6 units to the right and 3 units down to form triangle A prime, H prime, and prime on the coordinate plane. A figure is given. Then write the coordinate notation that describes the translation rule that maps triangle AHM to triangle A prime, H prime, and prime. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for here, learners? Right, we are to determine 2 things. First, the graph of the translated image, triangle A prime, H prime, and prime on the coordinate plane. That is what is meant by translate triangle AHN. Second, to write the coordinate notation that describes the translation rule. What are given here? The triangle AHM is to be translated 6 units to the right and 3 units down. A figure of triangle AHN is given. Okay, so we start with the first question and examine closely the given information that would help us answer the question. Here, we are to translate triangle AHM or push triangle AHM 6 units to the right and 3 units down to form triangle A prime, H prime, and prime. We will push the 3 vertices one at a time starting from point A. Let's go. From A, we count 6 units to the right, then count 3 units down. This is where A prime is now located. From H, we count 6 units to the right, then count 3 units down. This is where point H prime is now. From N, we count 6 units to the right, then count 3 units down. This is where point N prime is now located. Next, we connect points A prime, H prime, and N prime to form triangle A prime, H prime, and prime. Here is now our answer to the first question. We now have the translated figure, triangle A prime, H prime, N prime, which is the image. Next, we will write the coordinate notation for the transformation rule that maps the preimage to the image. Remember that for translation, we have this form. All we need to do is to plug in the values of A and B in our notation. A being the push along the x-axis, and B the push along the y-axis. The problem states to translate triangle AHM 6 units to the right and 3 units down. What does the statement imply? That A, the push to the right, is positive 6, and that B, the downward push, is negative 3. Substituting these into the notation, we have xy is mapped to x plus 6, y minus 3. So the coordinate notation for the translation rule is, there you are, learners. That was easy. Okay, let us summarize what we have learned in today's video. We have learned that, first, a rigid transformation is a process of moving any two-dimensional geometric figure in space or on a coordinate plane, and translation is one type of rigid transformation. Second, translation slides or pushes an object. Third, the coordinate notation for the translation rule that maps the preimage to the image is xy on the preimage is mapped to x plus minus a, y plus minus b on the image, where a is the horizontal push or slide, with positive when the push is to the right and negative when the push is to the left. B is the vertical push or slide, with positive when the push is up and negative when the push is down. Fourth, the graph of the preimage and the translation rule will help you locate the graph of the image. Fifth, the graphs of the preimage and the image will help determine the coordinate notation to describe the transformation rule that maps the preimage to the image. Sixth, after a translation, the size and shape of the image do not change. The side lengths or distance and the angles are preserved. We say that the preimage and the image are congruent. Orientation is not changed as well. Seventh, congruent figures are figures having corresponding sides that are congruent and corresponding angles that are congruent. Eighth, angles are congruent when they have the same measure, and sides are congruent when they have the same length or distance. Ninth, if you are given that two figures are congruent but no illustration comes with it, their corresponding parts can be identified through their names. The order on how the letters on their names appear will tell you which part correspond each other. The first letter on the preimage corresponds to the first letter on the image, the second to the second, and so on. 10th, when solving a problem, you must read it and may read it several times to know what you're looking for, what information are given, and to figure out how the information can help solve the problem. 11th, when a figure is given, make use of it. It is there to help you in analyzing the problem. There you are, learners. Hope this video helps. That's it for now. If you have any question, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will